Okay. Welcome to the TV Happy Math Hour, weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. So now at this time, please mute your mics for best sound experience, otherwise the feedback could interfere with the information we will be sharing today. Without further ado, here is Yvette Chuca.
Hello, everyone. If you are taking Math 1324, they just put the link in there. So I'll give you guys a few seconds to switch rooms if you are here for 1324. All right. Hope everyone is doing well. So for the 1314, we will be talking about basic matrix operations and using matrix operations. So at any time, if you have any questions, feel free to put it in the chat. And for this topic, it was really, well, not difficult, but there are some ways for us to use our calculators or our computer programs. And so what I decided to do is show you the basic ones by hand. And then at the end of the session, I will be putting a video to how to use the different software that you can use to help you check your work, for example. Okay. So the first few slides will be on section 8.1. And so the big question here is, what is a matrix? And so we've heard of this word matrix, and so we might be thinking Keanu Reeves, The Matrix. But unfortunately, that's not the case for our math class, right? We're going to be talking about, although matrices played a role in making that movie, but we are going to talk about this type of matrix. So a matrix is a rectangular array of numbers. And these numbers in here, these are all called entries, okay? And whenever we want to name a matrix, we use capital letters. So we always use capital letters to name your matrix. So here's the formal definition. I'm not going to go into detail with it, but just really quick, the subscripts that you see here, the first number represents the row, and the second number represents the column. So it's kind of like a location. So if you see something like A32, that's telling you to go to the third row, which would be here. This is the third row. And the second column. So the number that we would be looking at would be this guy here. Okay. So it's the address, the location. So matrices, as I mentioned earlier, they play a big part of the world that we live in, but we don't really see it in play because a lot of it's done in the computers in the backgrounds. So one example I can give you on the top right, you have the Super Mario game. And so this game is uses matrices. They use matrices to do animations. So they make Mario hop or move to the left or move right. So they use matrices to make that happen. Another way that matrices can be used is on the lower left. They use algorithms that use matrices to rank the pages on the internet, for example. And then another one, this is an actual picture of when 9/11 happened. They were trying to link certain people, friends and stuff like that. And so like the FBI agencies will use this to track who is related to who. And then in business, they also use the matrices as well. Okay, and it's used for coding as well. So that whenever you hear the word dimension, or you might hear the word order, what they're talking about is the size of the matrix. And the size of the matrix is given by the rows and columns, okay? So for example, this matrix here has the same number of rows and same number of columns. and it actually has a special name. It's called the square matrix. And we say that it has two rows, so the rows are going horizontally, and then the columns are vertical. So you have one row here, two rows, and then two columns. This one's called the row matrix because it only has one row, and then it has two columns. This one's called the column matrix because it has one column and it has two rows. So this is one row here, and then you have your second row here. And then this matrix here is going to play a big role in the rest of the sections. We call it the identity matrix. And if you notice on the diagonal, this right here, this is the main diagonal. And if it has ones here and zeros everywhere else, then that's going to be your identity matrix. And it kind of works like the number 1, okay, which we'll talk about later. Okay, so determine the dimension of each matrix. And so here I have 4 matrices on the left, and I have a bunch of dimensions on the right. So for letter A, which one would it match to from A through G? Okay, so what is the order of matrix A? How many rows do we see? And how many columns do we see for this one here? I guess I should say lowercase a. So we have one row, right? And we have one column. So this is going to be letter G. And then for the next one, for letter lowercase b, we have one row. This is one row. And then we have 1, 2, 3, 4 columns. So my order is going to be 1 by 4. Okay, so that's going to go to C. And then for this one here, which is called the zero matrix, it has 2 rows, right? 1, 2. And it has 2 columns. So this would be 2 by 2, which is going to be letter B. And then this one has 1, 2, 3 rows. And this one has 2 columns. So that's going to be letter D. Okay, all right. So that's again writing the size or the order of the matrix, which they call dimension. Another thing that we're going to be looking at is the augmented matrix. And basically the augmented matrix comes from a linear system. So here's your linear system. And we want to convert this system into an augmented matrix. And so the augmented matrix, the numbers in here make up your coefficients. And these numbers over here is your constants. Okay, so if you notice here for my x, I have a 3. So that's going to be my 3 here. I have a 5. So that's going to be my 5. And then my constant is -9. And then the constant for 1, the coefficient for x is 1. The coefficient for y is 4. And then we have -10 as our constant. So you have your x, your y, and then this is your constants. Okay, so if you wanted to write the augmented matrix here, see, they give us the system. So we need to consider the variables. So on the left side, you'll have your x, y, z, w. And then on the right side, you'll have your constants. So coefficient for x is 1, 3, -1, and then my constant is 9. And so we would have the second one would be negative. Oh, let me, so we have our x is 1, our y is 3. But if you notice here, there's no z, right? So we have to make it be a 0. And then you have your -1, and then the 9. The second one, there's no x, so we start off by putting a 0 because we need a placeholder there, so 0. Then we have our -1, z is 4, and w is 2, and then our constant is -2. Then we have our coefficient for x is 1. I don't have a y here, so that's going to be 0. Then we have -5, -6, and 0. And then the last one we have 2, 4, -3, there's no w, and then 4. So the order is 4 rows, 1, 2, 3, 4, and 5 columns. Okay, any questions on that? Okay, so here they want us to go reverse. This time they gave us a matrix. But what is a system? So where did this matrix come from? And so if you notice here, if you want to remember, this is your x and your y. So we have, this is the coefficient for x, so we would have 6x, 5y, and then my constant is 2. And you'll see either a solid black line or these dotted lines that separates your constants. So anything after that line is going to be your constants. So the line kind of works like an equal sign. Then you have your 3 for the coefficient of x. -9 is your coefficient of y. And then 0 is going to be your constant. Okay, so write the system of linear equations. So again here, my variable for this is 1, so that's going to be for x. I don't have a y. And then if you don't see this line, more than likely you should have the line here. So let me go ahead and add it. Or you should have the dotted lines that WebAssign uses. And so this system would just be x is equal to 4 and y is equal to 3. Okay. And so this is actually what we're going to be working towards. So we want to use matrices to solve a system. And there's 3 row operations that we're going to use. One is to interchange the 2 rows. So we're going to switch rows, and I'll give you an example here in a second. We can multiply a row by a non-zero constant, and we can add 2 rows together. Okay. So our goal, this is what we're going to want to do. They're going to give us a system like this here. And then we're going to write it into its augmented matrix. We're going to perform some of these row operations. And then our goal is going to be to have this identity on the left side, which is all ones here and zeros everywhere else. And we call this reduced echelon form. And so we want our answer to look like this. And the reason is because then if it looks like this, when I write it back as a system, I can say that x is equal to 4 and y is equal to 3 just by looking at this system. Okay, so that's going to be our goal. So when we say interchange, we just mean to switch the rows. So for example, in the original matrix here, we have 0, 1, 3, and 4. If we switch row at 2 and 1, then we would write row 2 as row 1. So here we have -1, 2, 0, 3, and 0, 1, 3, 4, and so on. Okay, so that's what we mean by interchange. To multiply, you can multiply by a half. So for example, if I multiply this row 1 by a half, what you're doing is you're multiplying 1/2 times 2 gives me a 1. 1/2 times -4 gives me the -2. And 1/2 times 6 gives me the 3. And 1/2 times -2 gives me the -1. So this right here is just telling you what we're going to be doing. Multiply a half times row. But if you see it like this, it says 1/2 times row 1 with an arrow. The arrow means to put your result back into row 1, just like we did here. I multiplied by a half here. Whatever I got, that's what I use for my row 1. And then the third one is to add -2 times the first row of the original matrix. So this is what's happening here. They are multiplying -2 to the first row, and then they're going to add it to the third row. So what they're going to do is -2 times 1 plus this number. Okay, so that's going to be -2 times 1 is -2 plus 2 will give me that 0. Let me do that again. So -2 times 1 plus 2 will give me this 0. -2 times 2 is -4 plus 1 gives me the negative 3. And negative 2 times negative 4 is 8. Plus 5 gives me the 13. And negative 2 times 3 is negative 6. Plus negative 2 gives me negative 8. Okay. So let's practice converting this or using a matrix to solve the system. Now in chapter 7, you also saw that you could solve the system by graphing. You could solve the system by substitution or addition. And now we're adding a new way, which is by matrices. Okay. So for these simple ones, you might be questioning, well, why can't I just use this chapter 7? But sometimes you have a bigger system, and matrices will make it easier to solve the system, especially if you have to use a computer to help you do that. So first, we need to remember what our goal is. Okay, so our goal is we're going to take this system, write the augmented matrix, which I did here. We're going to use the row operations. And our goal is that we end up with something like this. Okay, so let me put my line here. Because once we have this, then I can say that x is equal to A and y is equal to B. Okay, so since my goal, let me write my goal up here. And I guess let me give you a suggestion here. Always try to work with your diagonal first, okay? Because if you don't, then you're gonna be doing extra work. So what I always start with is I always wanna make sure that this number is a 1. So I'm gonna do everything I can to make this number a 1. And we go from left to right. So here I don't have a 1. The 2 is not a 1. I could make it a 1 by multiplying by a half, but then I notice that below it I have a 1. So I can use the row operation that says here I'm going to switch row 1, and then the arrow, the double arrow just means to switch with row 2. So I'm going to take this matrix here, and I'm going to write it as my first row, and then I'm going to take that first row, make it into my second row. And so here I switch them, right? So this one is now on the top, and this one is now on the bottom. And so far I've completed my goal of having a 1 in this upper left diagonal. So now you're going to use this 1 to make everything below it a 0. Okay, so how are we going to do that? What I'm going to do here is I'm going to multiply my row 1 by a negative 2, and then I'm going to add it to row 2. So for example, if I multiply this by negative 2, then we get negative 2. Negative 2 times 1 is negative 2. And I'm going to add it to row 2, and that's going to give it a 0. Okay, so that's what that means right here on the right side. But you can see it on the next slide. So again, I'm going to multiply negative 2 times 1 plus 2 gives me 0, and I'm going to place it below the 1. But we have to do it all the way across. Okay, so now I'm going to take the negative 2 times negative 1, and I get negative 2 times negative 1, and I'm going to add the 4 plus 4. So that gives me a 6, so that goes below there. And then the third one is negative 2 times 5 is negative 10 plus 8 gives me a negative 2. Okay, so now if we're looking at our goal, we have the 1 and we have the 0. Okay, so next we want to work with this diagonal. We want to make this a 1. So we have a 6. So your goal is to change that 6 to a 1. Okay, so some of us might think of it as, oh, I can divide by 6. 6 divided by 6 is 1. When in matrices, we really don't use the word division, but we can say that we're going to multiply, because that was one of the operations, right? We can multiply by any non-zero number. So I'm going to multiply by 1/6. Okay, so here I have just this matrix here. I just copied it down here. That way we have more space. So we're going to multiply 1/6 times row 2. And what is it that you're trying to change? You're trying to change row 2. So that's why I have my row 2 here. So here's my 1/6. So I'm going to multiply times 0. And I'm going to multiply times 6. And I'm going to multiply times -2. Okay, so 1/6 times 0 is 0. 1/6 times 6 is 1. And 1/6 times -2 is -2/3. I mean -2/6, which I reduced to 1/3. Okay. So at this point, what we're using is also called Gaussian elimination. And so from here, you could already solve the system, because for sure we know that this row here is telling me that y is equal to -1/3. Okay, but we're going to go ahead and write it reduced echelon form, which means that the number on top of the 1 has to be a 0. So if these have to be a 0 here, well, I can just add 1 plus -1 would give me a 0. So the way I'll write that is I'm just going to add row 2 plus row 1, and then you always want to put what is it that you're trying to change. We're trying to change row 1. Okay, so let's go ahead and add those. So 0 plus 1 is 1. 1 plus -1 is 0. -1/3 plus 5 is going to be 14/3. Okay, so we need a common denominator, which is 3 times 5 is 15 over 3, and then -1 gives you the 14. So since we have our goal, right, we have our identity on the left side, we can now say that our solution is going to be x equals 14/3 and y equals -1/3. Any questions on that one? Okay, I have another one here. So we have our goal. This is a different problem. So the first thing is they give us the augmented matrix already. Okay, so we want this to have a 1. Can I switch rows? You could, but is that going to give us the 1 that we want? It's not, right? So if you want to, and that's the other beauty of this, if I sit down next to, let's say, Mr. Carizales, and we're working the problem, we could both be doing something different, but at the end we'll end up in the same with the same solution. Okay, so I'm not going to switch rows because it's not going to help me, but instead, if I want to make a 1, okay, something you can keep in mind is if you want to make a diagonal of 1, just tell yourself I need to multiply by its reciprocal, its opposite, by its reciprocal, and then make sure that it's positive. Okay, so for example here, -3 times -1/3 is going to give me the 1 that I need. Okay, so if I had a 6, I would multiply by the reciprocal of 1/6, and so on. Okay, and that's always going to work from left to right. So we're going to multiply -1/3 times -3 is +1. So I put it here. -1/3 times 4 is -4/3. Notice I'm not doing anything to the second row, so if it helps, you can write it out. That way you don't get confused with it. And then -1/3 times 22 is -22/3. Okay. And this should just have an arrow pointing to the right, not a double arrow. So now I have my 1, so I'm happy about that. Now I need to make the number below it a 0. So anytime you want to make something a 0, then you could think of it as I'm going to multiply the 1 by the opposite sign of whatever's below it. So I have a 6 here. I'm going to multiply the 1 by a negative 6. Okay. So we're going to multiply row 1 by negative 6, and then we're going to add it to row 2, and our answer would be put in row 2. And so this is what I mean by I'm not going to change row 1 at all. I'm just going to write it here because I don't want to change it. I'm going to use it, but I'm not going to change it. And then I'm ready to do my work. Negative 6 times 1 plus 6. So negative 6 times 1 plus 6 gives me 0. So that's going to go here. And then negative 6 times negative 4/3 plus negative 4 is going to give me negative 6 times negative 4/3 is going to give me a positive 8 plus the negative 4 gives me a 4. And then we go to the third column, negative 6 times negative 22/3 plus 28. So negative 6 times negative 22/3, that's going to be negative or positive 44 minus 28 gives me 16. Okay, so now I have my 0. So now we want to change the next diagonal to a 1. So we want to make this a 1. We're going to multiply by its reciprocal, which is going to be 1/4. Okay, so again, this I just wrote this matrix, I just wrote it down here so we can continue. So I'm going to multiply this second row by 1/4. And whatever answer I get, I'm going to place it back in the row 2. Okay, so row 1, I'm not going to do anything with it. So I'm just going to write it out. And then for row 2, we have 1/4 times 0 is 0. 1/4 times 4 is 1. And 1/4 times 16 is 4. Okay, so now I'm happy because I have my my next step done. So now I need to make this number a 0. So since I have a negative 4/3, earlier I mentioned we would multiply the 1 by its opposite. So opposite of negative 4/3 is positive 4/3. So 4/3 times row 2, and then we're going to add it to row 1. And whatever answer I get, I'm going to put in row 1. So I'm not changing row 2. So I'm just going to write down my row 2. And then I can do my work. 4/3 times 0. Let me get my pointer. 4/3 times 0 is 0 plus 1 gives me 1. So that goes here. 4/3 times 1 is 4/3 plus a negative 4/3 is going to be 0. Okay, right here. And then the third one, 4/3 times 4 is 16/3 minus 22/3 gives me a negative 6/3, which is going to be negative 2. So now if you notice, I have my identity on the left. So I know these are my constants. So my solutions would be x is equal to negative 2 and y is equal to 4. Okay, any questions on that one? Okay. So now it gets a little bit bigger for my classes, especially when we're face-to-face. On a test, I would say you need to show your work for a 2x2 at least. For a 3x3, you could use a calculator. And so yes, you can use calculators to solve these. And so in the video I'm going to provide for you, you can, it'll show you how to do that if you're interested in looking at that video. So anyway, so here, the first step is, oh no, okay, I have written it down, I guess, but it didn't copy over, so I can just write it. So my first step is to write our augmented matrix. So I have negative 3. I have a y, which is 2. And what do you notice about this? It has 3 equations, so I should have 3 variables. So I'm going to have my z, which is 0, and then my constant, negative 28. Okay. So now my second row is 3, 4, and 0. And then we have a 4. And then the last one here is 4, -8, and 0, 36. Okay. So the first thing we want to do is change the, I guess my niece found me. So my mom's watching her in the other room, but I guess she found me. But they're going to go outside. Anyways, so here we have this number. We want to make it into a 1. Okay, so I'm going to go a little bit quick on this one, just because I want to show you something and not run out of time. But to make that a 1, what would I need to multiply that -3 by? So -3 times what would give me a 1? 1/3, -1/3. Yeah, so we're going to multiply by -1/3 times -3 would give me a 1. -1/3 times 2 would be a -2/3. -1/3 times 0 is 0. And -1/3 times -28 is -28/3. Okay. Did I do anything to the second row? Okay, let me erase this. No, right? So I'm going to just write my second row here. And I didn't do anything to my third row. And what was that, number 36? Okay. So now I need to make that 3 a 0, and I need to make that 4 a 0. So I'm going to start, let's start with the 4, only because it's going to make this problem end a little bit quicker. And so I'm just trying to illustrate something really quick. So I'm going to multiply -4 times 1, and I'll write it down here. So again, what I'm trying to change is the last row. So let me just write these out. That way we know that we're not trying to change these right now. So what is -4 times 1 is -4. And if I add it down here, plus the 4 gives me a 0. And then -4 times -2/3 is positive 8/3 plus -8 is going to be what? So we get 8/3 and minus 8. So that's going to be 24/3. Oops. 16. That's, I think it's 16. So let's put 16 here. It will be a -16/3. -2/3. Ruben, is that what you got? So -4 times 1 is 0. -4 times that is positive 8/3. And then plus a -8. Okay, so again, so what I'm doing is -4 times -2/3 is positive 8/3 plus a -8. And then -4 times 0 is 0. And then times 4 times -4 times 0 is 0 plus 0 would be 0. And -4 times -128 is it's positive 112. So let me write it on the side. Divided by 3 plus 36. Okay, so if I add a common denominator here, that's going to be 108 over 3. And if I add that, is 220 divided by 3. Okay. Okay, so now we want to change that 3 to a 0. And I thought I had, let me check something really quick. Because I thought I had it in here just to save us some time. Oops. I have it in here. So let me just share my screen really quick, and then if we have time, I'll come back and share this. We'll work it out again. Because when I convert from PowerPoint to PDF, it doesn't show me the steps. So here, this is where we were at right now. Okay. So if we start to change the 3 into a 0, and we do the work, we'll get the 1. But once we're at the 1 and you try to change the numbers here, then notice what happens at the very bottom. This, by multiplying this by a negative 8/3 to make it a 0, then at this point right here, let me get my red pen out. When we multiply negative 8/3 here, then we're going to get a 0 here, and negative 8/3 times 0 is going to be a 0. So we end up with this here. Okay. So notice that we have zeros all the way across. And so if you were trying to change this, if it was a 1, then you would know that it was z equals 196/3. But remember, you have this line here. So what this is telling me is that 0 is equal to 196 divided by 3. And that is not the case, right? So then that makes it impossible. So that system is not going to have an answer. Okay, let me get the file back. So again, in a little bit, if we have time, I'll come back and work it out step by step. That way you can see it. I just want to make sure we get to the rest of 8.2. So again, on the bottom, if you get something that says like 0 is equal to some number, then you know that that's not going to have a solution. Okay, I'm just sliding down to get to the file. Okay, so at the end here, we ended up with a bunch of zeros. And I already forgot what the number was. So I'm just going to make it up. Let's say it had a 2. Then this is telling us 0 does not equal 2. So you would write impossible as your solution. So it does not exist, right? So in 8.2, these are some of the definitions that we're going to be using. Two matrices are equal when they have dimension and the same corresponding entries. Okay, so corresponding entries just means if I have these two matrices here, the 1 corresponds to the 5. Okay, and they're going to be equal if they're exactly the same, which in this case they're not. So these are not equal. You can add two matrices if they have the same dimension. And then if they do have the same dimension, then we just add the corresponding entries together. And then we have something called scalar multiplication, which just means that you're going to multiply by some number to every entry in the matrix. Okay, and I have examples of this here in a second. Two matrices can be subtracted if they have the same dimension. And if they do, then you just subtract the corresponding entries. Or you can change it to addition and use scalar multiplication. So here b I can multiply by -1. And so this side here would be the same as this. So for the matrices below, find A, given A and B, we want to find 3A. So here, the 3 is what we call scalar, and we're going to multiply it to everything in A. Okay, so we have 3 times the matrix A. So I just wrote down the matrix A. And what we're going to do is multiply 3 times everything in here. So you can see the 3 is being multiplied to every single element. And so if we simplify, then we get 3 times 2 is 6, and so on. Okay, so that's how the scalar multiplication works. For b, we have negative b. So here we can think of the negative as a -1. And so that would be your scalar. And then you have your matrix B. So this is my matrix B. And so we're going to multiply -1 into everything. So -1 times 2, -2. -1 times 0 is 0, and so on. Okay. And then last, we want to subtract 3a minus b. So 3a minus b, we already know what 3a is. We have it down here. So I can just write it out. And I know what negative b is. It's right here. So I can just write it here. And so to add, and we should have checked that first. I always tell my students to do that, and I didn't do it myself. But the order here is 3 by 3. So they have the same dimension. That means that we can add and subtract. And so we're going to do corresponding entries. So I'm going to add 6 plus -2. And then we're going to add 6 and 0 together, and so on. And so that's what I mean by corresponding entries, 12 and 0, and so on. Okay, so 6 plus -2 is 4. 6 plus 0 is 6, and 12 plus 0 is 12. -9 plus -1, -10. 0 plus 4 is 4. -3 and -3 is -6. 6 plus 1 is 7, and 3 -3 is 0, and so on. Okay. So in WebAssign, the problems look something like this. If possible, find a plus b, and so on. And one of the common questions that I get every semester is, Ms. Chuka, my answer should be a 3 by 3, but I only see 2 rows and 2 columns. So I don't know what to do to enter all my answer. And so I always send a screenshot. These arrows here that you see, you can click on them to add more rows or to add more columns. Okay, so you can click this to add another row, or you can click, to add another column, or you can click this to add another row. Or maybe you need to subtract the row, then you can use the other arrow to remove a row or a column. Okay, so I wanted you to see this picture just in case you run into that problem here. So it says add a plus b. So first thing you should do is check your order. So this order here is 2 rows and 3 columns. And this is 2 rows and 2 columns. So they don't have the same dimensions. So that means that we cannot add these together. Okay, so they don't have the same order. So the answer would be impossible. And WebAssign does want you to enter the word impossible. Okay. I don't think it matters if it's capitalized, but since I see it capitalized here, then I would just enter it capitalized, but I don't think it matters. Okay, so another question, these are exactly from WebAssign, is software X and Y. So the only thing that they give us here, let's look at the left one first. So the left problem right here. The only thing that we have here is that they are equal matrices. So that means since they're equal, whatever I see here has to be here. So for example, -4, there's a -4. 6, there's a 6. So this x has to be whatever this is, which is -3. So I'm going to have x is -3 and y is 21. Okay. So let's look at this side. I have 18 is 18, 5 is 5, and then I have x and 2x plus 5. So I can write x is equal to 2x plus 5, and then 16 is equal to 5y minus 4. And so I'm trying to solve for x, so I'm going to go ahead and subtract 2x, so that gives me a -x is equal to 5, and divide by -1, so that gives me x equals -5. Y, I'm going to add 4, so that gives me 20. Divide by 5, that gives me 4. Solve for x in the equation. So we're trying to solve for x. In this case, I already solved for x. So we can just substitute our matrices. So here's my x is equal to 2. A is this right here. And then B is this matrix. So first I can do the scalar multiplication. So I'm going to multiply everything by 2. So 2 times -3 is -6. 2 times 2 is 4, and so on. And on the right side, 2 times 3 is 6. 2 times 2 is 4, and so on. Okay. Again, you can check the order, but the orders are the same. This is a 2 by 3, 2 by 3. So -6 plus 6 gives me a 0. 4 plus 4 gives me 8. -6 plus -10 gives me -4, and so on. Okay. Now in this one, they still want you to solve for x. So I encourage you to take this equation here and solve for x first before you insert any matrices in there. And what I mean by that is, since I try to solve for x, so I'm going to move 2x to the left side, and I'm going to move 4b to the right side by subtracting 4b. And then for my x, you can divide by 2 here. So we get x is equal to -a, and then 4 divided by 2 is 2 minus 2b. So now that we have our equation, we can plug in what we have here. So if there's a negative, you can have -1. A is the matrix, and then -2, and then B is the matrix. So we do the scalar multiplication, multiply everything in here by a -1, and everything in here by a -2. And so now we're at this point, right? I'm going to add 2 plus 0, -1, -4, and so on. Okay, so my answer would be here. Okay, so if you work with the actual equation first and then substitute your matrices at the end, it will be a little bit clearer. So multiplication of matrices. In order to be able to multiply a matrix, you always want to start off with looking at the dimension, the order, okay? So here, for example, you have this matrix A is a n by n matrix, and this matrix B is a n by p. So in order for you to be able to multiply the number of columns in this first matrix, which is n, has to be the same as the number of rows of the second matrix. If these are the same, the inner numbers here are the same, then that means that you can multiply. The outside numbers, these right here, that's going to tell you the size of your product, okay? So in this case, if you multiply, your result would be an m by p. So for example, here first you start off by looking at the order. So this is 1 by 2, and this is 2 by 1. You look at the inside numbers here. Notice that they're the same, 2 and 2. That means that yes, you can multiply. And the outside numbers, which I have in green here, tell you how big your answer is going to be. So your matrix that you come up with is going to be a 1 by 1. Okay. So how are we going to multiply? You're going to take your first row, which is this here, and you're going to multiply it by everything in the first column. So we're going to say 4 times 1. So 4 times 1. And then we're going to take your second number, 1 times 2. Okay. And whatever the result is here, we add them together. So 4 is 4. 1 times 2 is 2. 4 plus 2 is 6. So again, it's the first number with the first number, the second number with the second number. And it's the row by every column that you see. In this case, we only have one column. So for example, here you have a 2 by 1 and a 1 by 2. So the inside numbers, they're the same. That means that yes, you can multiply. And the answer that you get is going to be the green numbers here. It's going to be a 2 by 2. Okay. So the first thing you want to do is you look at the row, which I underlined here by this orange line. So I'm going to take this row by this column. Okay. So I'm going to multiply 1 times 4, and then there's nothing else here. And notice I keep the same row, but I go on to the second column. So now it's going to be 1 times 1 for my second number here. And I have no more columns, so I can move on to the second row, which you'll see underlined here. So now we start again. So the second row is 2 times the first column, 4, and then 2 times 1. And so now I have my numbers here, so I can simplify. 1 times 4 is 4, 1 times 1 is 1, 2 times 4 is 8, 2 times 1 is 2. Okay. Find a squared where a is this matrix. So a squared is just a times a. So here's a and here's a. We want to see if we can multiply it, so I check the numbers. The inside numbers, which are in red, are the same. And so my result would be the green numbers, which is 2 by 2. Okay, so the way we multiply is, notice here I underlined my first row because I want to focus on the first row. And then I'm going to focus on my first column. So I'm going to multiply 3 times 3 plus 1 times negative 1. Okay, and then do I have more columns? Yes, I have this column. So I have to use the same row times that second column. So 3 times 1 and 1 times negative 2. Do I have any more columns? No. That means I can go to the second row, which I underlined here, and I start again with the first column. So negative 1 times 3 and 2 times negative 1. And then I go on to the next column, negative 1 times 1 and 2 times 2. And then I just simplify in here. 3 times 3 is 9 plus a negative 1. And so we get 3 times 2, or 3 plus 2, negative 3 plus negative 2, negative 1 plus 4. And so that's going to come out to 8, 5, negative 5, and 3. Okay. So again, when you're multiplying, first thing, always check the rows and the columns, the order, the dimension. So this is a 2 by 2. This is a 3 by 3. Notice that those inside numbers are not the same. So we say that it's impossible. Okay. As I mentioned earlier, you can use a calculator. And so the only thing with the calculator is, depending on your instructor, they might not allow a calculator. If you have a TI-8384, you can use it. Some of the smaller calculators, like the Casio's 115 and so on, those might let you, but it might be up to size 3 by 3. And then you can use some websites, like you can use Decimals, and they also have a calculator in there that you can use. And so the video, let me get the link for you. That way you can have it. You can use it to just see if you want to use a calculator or not. Let me see. While I look for the video, let me know if you have any questions. I'm going to put the link for the sign in as well. I don't know if somebody already put it or not. And then also if you signed up, if you've gone to my YouTube channel, then you'll see that you have some videos there for this section as well. Okay, so this is the link to, it just talks about different tools that you can use. So that's that link. And then let me give you another link for Chapter 8 videos. These are showing you how to do like the first examples that we did. And just forgive my voice on these that I'm about to send, because I was sick when I did them, which was a few years ago. So I'm just sending them because they go over the same questions. So those are 3 videos that you can use to see more examples. Is there any questions? And I guess we have like 4 minutes. Let me show you. Let me see if I can pull it up. How to do it on your graphing calculator really quick. So let me share my screen and then tell me if you can see it. What do you guys see anything right now? Do you see my calculator or no? Not yet. Okay, let me share the different screen. Okay, let's share entire. Can you see a graphing calculator? Okay, so if you want to enter in your calculator, you would go to second matrix right here, where the x minus 1 is, and then you want to edit. So if this is a 2 by 2, you would enter 2 by 2, and then you enter numbers 4, 5, 6, and 0. And then I'm going to quit, and I'm going to enter another one. Let's go to B, and I'll make this 2 by 2 also, just so we can do some stuff with it. Okay, so now that I have my matrices there, I just quit, and then I'm going to go second matrix. Let's say you want to multiply A, so I would select it and then just use my times. And then I'm going to go get matrix B. I come down to B, and then I press equal, and then there it is, right? If you want to solve a system, it's actually kind of nice too, because notice what happens here. I'm going to make this 2 by 3. Oops. And let me put a number in here. 6. And let's make that a 1 just in case. Hopefully I don't pick one that doesn't have an answer. And then, so notice now, if that's my augmented matrix, if I go to math and I go all the way down to our REF, which is the reduced echelon form. Oops, let me quit here. Which is the reduced echelon form. You can do what we were doing earlier. Watch this. You see how you have the 1, 0, 0, 1, and then you have so here my answer is x equals 1.5 and y is equal to 0. And so you can do anything with this calculator. But if you don't have one, it's okay, because the video that I put, you can also use those websites to help you do that as well. So anyways, I just wanted to show you that in case you have a graphing calculator. But of course, it depends on your instructor, right, if they allow you to use it or not. Any questions? Well, if not, then just let us know. We have tutors here waiting in case you have any questions. And if not, have a good weekend. And we'll see you next week. Next week will be using inverses, I think, if I remember correctly, which would be 8.3 and 8.4.
Alrighty. Well, I would like to thank Ms. Chuca and Mr. Carrizales for presenting today. Also, I would like to thank the audience for coming and being such a wonderful audience. And we hope to see you guys all soon, okay? I'm going to stop the recording now.